what value is that? What does it mean? It's a correlation coefficient. That r squared value is a correlation coefficient. And what do we want it close to? We want it close to 1. Okay? If the closer to 1, the more, the better the fit, right? The better the fit. Okay, so what is our quartic regression here? What was the A value? Negative 0.10. X to the 4th power plus, what's our B? 2.22 x cubed. What's our C? Negative 18.9. 5 or 6?
5. Oh, yes, 6.
Okay? And I'm going to put this in parentheses because I had already put a plus sign here. And since it's negative. What's our D? 86.82. Oh, it's close enough. You guys need to figure out how to round. What?
The first one's 0.1, not 10.
Isn't that the same thing? Negative 0.1 is the same as, there's a decimal. You just couldn't see it. There's a decimal here. Is that okay? Okay. And this is 86.82. Okay, X, and then what's our E value? One person not mumbling, please.
Negative 32. 1 minus 8.
Do we agree with this regression? Anybody? Okay, what's our R2 value? So our R2 value is 0.93. That's pretty good. Did anybody find a closer one? You did it to the 3rd? And what did you get for your 0.91? You did it to the cubic? You did cubic too? So I would have thought quartic simply because it came back down, and that end behavior is showing that it's coming back down. So on your test, it gives you a graph and it says, which one do you think would be the most accurate? Looking at a plot. And I would hope that if you saw that it was coming back down that you would pick quartic. Yes, sir? Okay, if you don't have an R2, okay, if you don't have the R2, this is what you do. Because I've said it multiple times, but only certain people listen. So, listen everybody. If you cannot find your R2 value, you go second 0, because you want to get to the catalog. Okay? And you scroll down until you find the word diagnostic. Diagnostic on. Okay? And then you hit enter until you see the word done. And then you go back in and go back to quartic regression so you can see your R value. One says diagnostic on, one says diagnostic off. You got it? Okay, so that's I have documentation that I've told everybody how to do this. Okay? Thank you. Okay, so if you go back now and look at this next one. Time since 7 a.m. Okay, so this is important. Time since 7 a.m. A lot of times when you're dealing with years and you're dealing with time, it's going to give you a starting point. Okay, so 7 a.m. would be your 0, right? That's your beginning. 8 a.m. would be the 1. This would be 10 o'clock. This would be 12 o'clock, and so on. And that's because if you're given something in years, and you're using your years as your input values, think about that if you use the year 2015. How do they determine where it crosses the y-axis when x is 0? How far back do they have to go? To the year 0, right? So if your R values are crazy, it could potentially be the fact that you aren't looking at what you need to start with, what your beginning point would be. A lot of times it will say, let 2010, or let your x values be time since 2010, or years since 2010. So 2010 would be your 0. And then from there you would...
So would you make 10 0?
What?
Would you make 10 0?
Where?
I don't know, like how would you input it? Or are you just telling us?
I'm just telling you, in general, like when you see a word problem and if it has your x values have to be in years, then it could potentially say, let your inputs be years since 2010. So wherever you saw the 2010, you would mark that as 0. And then if your next one was 2012, that would be 2. And then 4, and so on.
7 a.m.
In this case, 7 a.m. would have been your 0. Okay, so when you see the number 1 here, that's the same as 8 a.m., right? And the 3 would be the same as 10 a.m. And the 5 would be 12 noon, right? So 12 p.m. And then the 7 would be 2 p.m. And then 9, 4 p.m. And then 11 would be 6 p.m. So do you see how they did this? 8 p.m. and then 10 p.m. Okay, so what's happening here just by looking at the points? We're going from 5,700 to 7,000, and then down to 45, and then up to 68, and then down to 65, and up to, or down to 50, down to 37, up to 42. There's a lot happening here. Is this the one where you got awful R values? You got 0.54? Those are awful R values. Awful. Right? If you see something that's in the 0.4s, 0.5s, that is not a good model. You are not going to be able to use that equation to predict anything. Okay? That's what it means. There's no good predictor. So let's look at... So that's how you're going to do the 1 through 6, which hopefully you've started. 7 through 12 are just coming up with regression equations from 1 through 6. Okay, that's what they did. So that's why I said you should do it all at one time. Go ahead and come up with those regression equations while those values are put in that calculator. Okay, and then we get to the explanation. So we've got problem 14 is going to correspond to the regression equation from the problem 2 that we have on the board. Okay, so let's look at that for a minute. I'll go back to the equation. Use the regression equation for problem 2 to predict how many hours of work Jay will be hired for in October. Okay, so if I go back to that equation right here, I wish I could just cut it. Maybe I can. I don't know how, though. 14. So that should correspond with problem number 2, right? So can you guys recall this equation for me back over here so I can... let's put it down here. So, use the regression equation for problem 2 to predict how many hours of work Jay will be hired for in October. So, are hours of work your input or your output? It was your output, right? Output. I can't spell. Output. This is your output. So these are your Y values, right? Your output is your Y value. And then what about October? That's your input. That's going to be your X value. So this is your X value. So what would your X value be for October? 10. Do you all agree with 10? So our X value is 10 because our X1 was January, right? And that's when it was 1. Okay, so the other day I told you that if you are given an input and you're looking for the output, what feature do you use? Your table. Use your table. If you're given an input, and you're solving for output, use table feature. Okay? And how do you get to the table? You get here by doing second graph. Okay, now, if your X values, if it's not starting with where you want it to start, how do you change that? The same button as window, it says table setup. Do you see that? Table set, TBLSET. So if you want it to start with something else, then you go into second window and tell it where you want it to start. Have it start at 0 if that's where you need to see. And then that delta TBL, that means your change. Do you want it to change by 1? Do you want it to change by 2? Do you want it to, okay, so we want it to change by just 1. So you want that to be a 1, okay? And now if you go back into your table, you should see your answer. So what do you get when you have that equation in? Now that equation has to be in your Y equals in order for you to, you don't have a Y? That's because it's not in your Y equals yet. Make sure that that's plotted. Okay, but you don't have a Y. Go into Y equals, Audra. Is the equation in there? So let's put the equation in there. So what's our equation again? Negative 0.1 x to the 4th power. And that's all I can remember. What'd you guys write down? Plus 2.2, 2.22?
Yeah.
X cubed. 18 point, thank you. Guys, if you're not doing this along with me and then you ask me for help, I'm going to say no. 86.84x. 82. Okay, and then what? 31.88. Thank you very much. So what do you get? When your X value is 1, what do you get for your Y value there? Go to your table. When X was 1, what is your output? We're looking for when X is 10, sorry. What is it? Mine's not that, but maybe I input something